Well, it was previously calculated that the velocity right here was 24.2 meters per second, and that after this little leg of the journey, the velocity had increased to 27.8. Now we want to see how fast it is down there. Since it's starting to not be so steep anymore, we can expect it to slow down, particularly with a coefficient of friction above 1. So let's see. This particular segment here, let me draw the horizontal, is at an angle of 30 degrees, but also has a length of 30 meters. Knowing that it has an angle of 30 degrees means that we can start working out the forces. So the force pulling it down is going to be mg sine theta. The mass is 1, gravity is 9.8 as always, and sine is of 30. Now, sine of 30 is 1/2, so this one we don't even need a calculator for. The force downwards is 4.9 newtons. Okay, I can just go ahead and draw the arrow in now. That's going to be 4.9. Okay, as for the force of friction holding it back, that's going to be the coefficient of friction times mg cosine theta. Coefficient is 1.1. The mass is 1. Gravity is 9.8. And then there's the cosine of 30. Now the cosine of 30 is the square root of 3 over 2. So I'm going to let the calculator get that for me. 30 cosine times 9.8 times 1.1. There we have it. 9.34. I guess I've only got one digit there. I'll just go with 9.3. So, as expected, the force of friction holding it back is stronger than the force pulling it down, which means this will be slowing down. We just need to know by how much. And in order to find that, we need to get the net force. Since the force of friction is stronger than the force pulling it down, I could just do this minus 4.9, and I get 4.4. So this is the net force here. As before, since the mass is 1 kilogram, that means that the force is 4.4, the acceleration is also 4.4. Now, because this is slowing down, I need to be careful, that I actually get my velocity to decrease, right? So let me go ahead and plug things into this equation. 2a delta x equals v2 squared minus v1 squared. Since it's slowing down and I need my v2 to be lower than my v1, that means I can let the acceleration be negative to, make that be a deceleration. So if I wrote in here 2 times negative 4.4, okay, I got that from here. Delta x is 30, because every single segment has that length. That v2 is what we don't know. But the initial velocity was 27.8, because that's how fast it was at the end of the second segment. 27.8. Okay, so let me do some simplification here. If I take that and multiply it by 2 times 30, so I've got 266.1 145. I'm just writing down some digits so I don't lose them. Equals v2 squared minus 27.8 squared. Oh, I should find out what 27.8 squared is, right? 27.8 squared is 772.84. So this is 772.84 right there. So I should add that to both sides. Oh, by the way, that's negative. Sorry for missing that. So if I add that to both sides, I'm just going to subtract 266.145 from that. 266.145. 506.7. Let's be honest. 506.7. Okay, if I just take the square root, I'll know the velocity. 22.5. There we go. That's how fast that thing is going right there. So let me write that in, and then we can move on to the last segment. So right there at the end of the third segment, our velocity is 22.5 meters per second. Now, it's worth noting this only got up to 24.2. Since that has less than 24.2 meters per second, it won't make it to the end. Okay, we already knew that because coefficient of friction of 1 was precisely enough to get it to the end. Since we don't have 1, we have 1.1. We knew we were going to be short, but now let's find out precisely how short it's going to be, knowing that we're starting at 22.5 meters per second. Okay. Well, since we have an initial velocity of 22.5, and it's 0 degrees for 30 meters, well then, let's find the forces. Here's the easy one. It's not being pulled down the slope anymore because there's no more down. Mass is 1, gravity's 9.8. The angle, though, is 0, and the sine of 0 is 0. So it's not being pulled down anymore. The only force at work now is friction. So that's going to be the force of friction. The coefficient is 1.1. The mass is 1. Gravity is 9.8. Cosine is of 0. The cosine of 0 degrees is 1. So we've got 1 times 9.8 times 1 times 1.1. So 9.8 times 1.1, times 1 a couple times, 10.78. Which means on this last little segment, the only force acting is 10.78 newtons of friction, slowing it down. And as always, because the mass is 1 kilogram, remember that mass was selected because the mass doesn't matter, but we just have a number in there to make the math easy. Okay? Because the mass is 1 kilogram, that 10.78 newtons also means an acceleration, rather deceleration, of 10.78 meters per second squared. Now we get to finish the problem. This time we're not looking for a velocity, we're looking for a delta x because we are assuming a velocity. It started out at 22.5. It's ending up at 0. How far did it go is exactly the question we're asking while it's accelerating at negative 10.78. So 2 of negative 10.78. Okay? 2a delta x v2 v1. That's negative, everything works out perfectly. Let's just solve for delta x. We'll divide both sides by that. So delta x is equal to, the negatives cancel out, so I'm just going to leave them 22.5 squared over 2 times 10.78. All right, it's going to be less than 30. Let's see by how much. 22.5 squared divided by 2 and divided by 10.78. 23.5. Although, to 2 significant digits, really I only get 23. So, even though this whole segment is 30 long, it only makes it about, just eyeballing it here, about that far. It only makes it 23 meters, and it never makes it over there. Okay, so to summarize, just gather all these back up. The first one looked like this, okay? The final velocity after the first leg was 24.2 meters per second, and this is all the work for it. After 24.2 meters per second, it managed to get up to 27.8 because there were 8.49 newtons pulling it down, but only 5.39 newtons keeping it back up, giving us a net force and therefore a net acceleration of 3.1. So speeding up from 24.2 at an acceleration of 3.1 only got us up to 27.8. And after that, you've got, there we are, got to 24.2, then it got to 27.8. Down here, we finally have a force of friction stronger than what's pulling it down, 9.3 greater than 4.9. Here's the work for how you get 4.9 and 9.3. Yeah, okay. So that means it's going to slow down slightly to 22.5. And in the last one, because there is no more down, it's just slowing down at the end. We're beginning at 22.5 meters per second. It only makes it 23 meters down before the friction stops it because it was a force of 10.78. All right, that's the whole problem. It was a long and involved one, but I think you guys are up to it. Hope you did well and didn't sweat too much.